Professor Yagi, thank you very much for inviting us into your lab.
It's a pleasure.
I read that you've come up with a way to actually suck water out of the air and store it.
That's true. We use materials called metal organic frameworks, or MOFs, and these are constructed from metal ions that are in minerals and organic units. Here you have the organic building unit and the other of a metal ion. And we mix them together and stir to make the metal organic framework, or the MOF. And once you remove the liquid, this is what you get. And this is the material that is the MOF.
So what does that powder look like close up?
So if I zoom in on a granule of this solid, the structure does not look very much unlike this. The metal ion and the organic are linked together to make the framework that is the MOF, and it encompasses space. The liquid will bind to the framework, to the interior of the pores. 1/3 of the world population live in arid regions where water is scarce. But that air in those regions contains about 30% humidity. These materials can take up the water from that atmosphere, concentrate it, and deliver liquid water using nothing but sunlight and the MOF.
So depending on what kind of substance you want to attract and store, you actually change the kind of metal and the kind of organic material?
By using a longer organic unit, I can change the pore size. By choosing a different metal, I can change the metal composition so that I can do a different kind of reactions, absorbing different kinds of gases. This MOF is a star for natural gas storage. And if you put this in a natural gas tank, you can store 3 times the amount of natural gas than without the MOF. The purple one is very interesting because it traps carbon dioxide from the atmosphere and also from emissions in power plants to prevent carbon dioxide from reaching the atmosphere.
It seems like this has been a revolutionary invention that could change so much into the future.
When I started doing this research in the early 90s, I was interested in the beauty of molecules. I was not necessarily interested in making the new materials going to solve the world's problems. For a lot of problems facing society, such as water, such as carbon dioxide, these are tremendous problems that are being investigated using MOFs worldwide. And what remains is really the wide-scale deployment of these to actually serve society.